Yeah, everybody is fine.
Yes, sir.
Okay, generally we have completed this chapter, and I'm just going to see if anything is left. Okay, the last 2, 3 slides are there. I'm just going to quickly brief you about them, and then we were doing work on this Excel sheet, so I'm just going to open the Excel sheet as well. So just give me a minute. Okay, I'm just going to give you about brief you about how you can apply this regression on Excel sheet. So first of all, we are going to do that, and then we are going to apply in terms of multi regression. So I'm just going to share with you the screens.
Sir,
Please.
sir, students are asking to let them in the room.
Oh, okay. Just a minute. Okay, I'm actually opening various files, so I don't know where they. Okay. Okay, well, hopefully all of them have been joined. So thank you so much for informing me. Now I'm going to share my screen. So quickly, I'm just going to move on this last 2, 3 slides regarding simple linear regression. Just like we have last time discussed about this example, winning and score, how much relationship exists between them. So I have collected data and I identify that if you are going to create a regression analysis or run a regression analysis on the given data set, on raw data set or default data set, problem is that due to the large variation, line fit, which line is going to be fit is not so much accurate. It's not going to be a most accurately fit line. So for that purpose, we have taken the log. Log is doing what? It is going to reduce the excessive difference between value, but keeping one important thing intact, that is the difference between them, that is their ranks, that is their you can say the structural relationship. So that is not going to disturb, right? Therefore, whenever you are going to take log and then you run your regression, the most benefit is that you are capable to apply linear regression, and then you are capable to generate result, and then you can take anti-log, and ultimately you can have more clear-cut relationship, interpretation of that relationship, or you can say trend of that relationship. So different formation is possible for all kind of data set, which you can apply log. You can take log. You can take reciprocal. Reciprocal is 1 over given variable, just like 1 over x, 1 over. In our case, this example actually reflects this data winning. So score, how much you are going to win through taking some score, right? Or obtaining some score. So that kind of relationship. So we take the log of this winning, or we can take the log of the score as well. There is no issue, but it may be in that way that there are different options available for different models. So keep one thing in your mind. Models may be log-log, models may be linear log, log linear, linear linear, right? Double log model mean dependent and independent variables all are in terms of log. Log linear mean dependent variable is in terms of log, but independent variables are without any log. They are in original form, level. That is called level. So variables at level, variables in log, variables, and lag is a different thing, right? Lag is a different thing. So which are taken with one time period gap. So all these possibilities are there. Different kind of variables can be used. In case of linear log mean dependent variable is linear, original level at level, and the variables which are used as an independent variable, they are in log form. So this point is clear that these variables may have different structures, different relationship. So all possibilities are there. So you can take square if let's suppose values are that kind of thing that you need to take square or square root. Usually, you know that you go for this reciprocal square and square root only in case you believe that your model is non-linear and you are going to apply non-linear formulation. Even in terms of log, that is possible, but reciprocal square and square root directly identify that. Any question related to that? Because this is going to be winded up. I'm just going to move on Excel sheet and just doing some work where previously we have done mainly, but I'm just going to do that, and then we are going to get some result, and I'm just going to interpret that result. Clear? This chapter is completed, and then we are shifting on 14th chapter, which is related to the multiple linear regression analysis. So moving before that, I'm just going to use this data set. Last time we have observed that this trend line is not so much effectively capturing the data, but if we are going to use log form, that line of fit is more accurate, and the deviation of points from this estimated line, the original points, how much deviated from estimated line, this deviation is going to be squeezed, it's going to be reduced. It is just like that you are getting more closer and closer accurate value or accurate answer of your estimation. This is clear to everyone? Please, I just want to know that everyone is clear in this regard. Dear participant, my dear students.
Yes, sir, it's clear.
Yes, sir.
Yes, sir.
That's great. Okay, now you can calculate the same kind of relationship based on some kind of other technique. I'm just going to use that, but that is going to be actually applied in multiple linear regression. So I'm just going to use that there. Only thing here is that you got your intercept and your this is your slope variable, this is your intercept variable. So you have to calculate these, and you have to calculate your F statistics, which is showing that whether the regression is going to be explained or residual is larger. Regression is larger or residual is larger. In simple words, how you can explain the residual and how you can explain the regression. Whenever we are going to make a relationship between two variables, one way is to measure through correlation. Correlation is not going to identify the magnitude of impact as such. Correlation is going to identify only that there is some significant relationship between two variables. It is direct or indirect. So that is going to be clear. Regression is helping you to identify independent dependent variables. So direction of relationship is clear through regression, which is not clear through correlation. And secondly, the magnitude of impact, how much it is going to be caused. Whenever you are going to connect two variables in simple linear regression model, how much single variable, dependent variable, independent variable is going to affect dependent variable. This R scale is helping you to identify how much effectively that is going to happen. So if that variable, this value is very large, just like in this case, it's 0.93, 93% of variation in dependent variable has been explained by the independent variable. That is the way to explain that, right? So what it means, 93% variation. If dependent variable is going to change, sales are going to change, let's suppose independent variable is price, then 93% impact of price is going to happen on sales, right? So that kind of relationship is going to be explained by this R scale. F shows that how much independent variable you have incorporated into the model, which is explaining some dependent variable, how much effective this model is as a whole, right? Therefore, this F statistics, if larger and larger, then that is going to be more effective model, because what it means actually, same this regression, this how much variation is going to be captured and how much variation is left outside, which is not going to be captured through this model. That is the residual. So if smaller amount of residual is there and large amount of explained variation, this means your F value will be larger. And if your F value will be larger, it means straightforward that your model is strong, good model, effective model. Usually we need to brief or describe this F statistics in multiple linear regression models where more than one independent variable exists, because we want to consider that there are different sets of variables which we can implant in a particular regression to explain dependent variable. So let's suppose X, Y, Z, X1, X2, X3, X4 variables, Y1, Y2, Y3, Y4, Z1, Z2, Z3, Z4. So these are different set of variables. Let's suppose separately X variables, how much they are going to affect Y. Separately, how much, let's suppose your a dependent variable is D. So how much X variables are going to affect D, how much Y variables are going to affect D, how much Z variables are going to affect D, or different combination, X1, X2, Y1, Y2, Z1, Z2, this combination, X3, Y3, Z3, X1, Y2, Z3, is multiple combination you can have. And all these combinations, how much, which combination is the best one, you can judge through this F statistics, right? Along with this R scale, coefficient of determination. Clear? So this T statistics actually shows the significance, and here also significance is going to be shown through p-value. I will suggest you that if you are not going to consult any table, there is no issue. You can directly observe the p-value. If p-value is very small, less than 0.05, then definitely you go for significance result, right? Your results are significant. Significant always mean that your null hypothesis is going to be rejected and your alternative hypothesis on which you have your claim is okay. It's going to be accepted. Null hypothesis is not reflecting your claim. Please note this point whenever you are claiming anything. Just like in previous example, we observed winning prices are depending on scores. Just like in previous example, the example related to this results we are discussing, right? The data set. I think this one is the data set. So regarding this data set, if we believe that winning result or winning amount is depending upon score, that is our alternative hypothesis, which say actually it depends how much score you have acquired, so much winning amount you will have. So that kind of relationship actually you are identifying, and that is your alternative hypothesis. You want to prove it. If you want to prove it, you have to reject null hypothesis that there is no relationship between score and winning outcome or winning amount, right? So that kind of thing is there. Okay, now I'm going to jump on because the basic explanation is done here. I have already mentioned this residual plots. Now, residual plots are very clear if you just observe. Is there any specific relationship or specific structure is observable in a residual plot?
No, sir.
It is totally random, right? So
Yes, it's very random.
Whenever it is random, what it means?
So there's no particular relationship between these two variables.
No. These are residual plots.
Mm-hmm.
Residual
So what do
are test for. These are tested for model specification. Model is good. It's properly specified. It's not. It don't have any kind of misspecification or any kind of other problem, right? Model is accurately run, so it is generating accurate result. Clear? If these residuals have some kind of trend or some relationship, just like upward trend, rising, downward, some kind of cyclical trend or such any kind of specific trend you can observe by yourself, then your model has some problem. Your model is not a good fit model. It may have some kind of specification problem. Either you have to change your variables or you have to change the data set or the sample size so that you can have better result. Getting my point?
So, sir, we can say that if there is a trend in the residual plot, it means that there is, some bias in our method or in our model.
There are some problems,
So,
biases, any kind of other distortion or issues in the model,
okay, sir.
which need to be settled. Mean to say you cannot accept that model which don't have residual scores randomly dispersed. If they have some specified relationship, then you have to take care of that model.
So, what about the score line fit plot?
This
What
is
does
just like the plot to show that the line is going to be accurately fit or not. Just like if let's suppose I'm going to copy for your convenience here, where other plot lies.
Mhm.
If you just observe these two plots, actually plots are there just to identify your compare situation. Now you can observe these two plots. Data is same, but in one case data is looking more fit, and in other case it's fitting. It's showing less fit, right? So that is the thing. Only purpose is to show that whatsoever disbursement of the data, which line is the better fit. So whether you are going to select this line plot or this one, right one or left one?
So, right one.
Right one, right? Why? What is the reason behind it?
Sir, it gave a more clear and visible picture, while the other one is not that clear because there are some distortion or the relationship is not that clear.
Okay, where you will not say the distortion, you will say deviation are larger in left picture, right? In this picture, deviations are larger. In this picture, deviations are very low, right? So most probably errors are minimized in this picture, right picture, errors are not minimized in left picture. Even though this is the least square regression which we have applied, which actually leads to minimize the errors. But the problem is that data is not straightforward. It is not going to have linear relationship generally. Therefore, whenever we try to fit linear relationship, it shows some problem, right? So that kind of problem is there, that results are not so much effective. Once we are going to make forecasting, it is going to be deviate larger and larger. But in this case, if we are going to make forecasting, deviation may be there, but it is increasing very slowly. So more accurately, we can make forecast on the basis of this plot, this line fit compared to this line fit. Both models are applied with the same regression, but variables are taken in a different form. Here log form and here non-log form, linear form. sorry, level. Clear?
Yes, sir.
Okay. Any other student has any other query, please may ask. Okay, now we are moving towards multiple linear regression. First of all, one thing need to be clear that whatsoever we have learned through simple linear regression is equally applicable in multiple linear regression. Only thing is that additional variables are going to be incorporated in multiple linear regression. Whenever we are going to add more variable, it is just like if two players are playing game, then there are some rules which they both can set. But if three players are there, then three dimensions are there, three people have their mindset, and so more consideration or more discussion is needed. 4 player, 5 player. So whenever you are going to add more people in a system, then more thoughts are coming and more issues and more problems and more conflicts may arise. Same thing applies with the multiple linear regression model. Whenever you are playing with the two variables, dependent and independent, only two variables, then they variables whatsoever have relationship in isolation of other or keeping other thing constant, it can be observed in a brief way more easily. But whenever you are going to incorporate more independent variable, the relationship between x and y is going to be affected by z variable, t variable, c variable, whatsoever variable you are going to add. So the point is that the relationship between dependent and independent variable original, that may be affected due to the another person or another variable to the system. And secondly, the variable which has been incorporated as independent variable, it may have any kind of relationship with existing independent variable. Just like x1, x2, x3, x4, all these are independent variable. You use x1, then you add x2. Now x1 and y relationship is going to be disturbed maybe due to x2. Or you add x3 in this way. But on the other side, x1 and x2 may have some kind of relationship. So that need to be actually observed. So whenever, just like in a company, people are going to be hired by the employer, just like you say, the employer business is the dependent variable, and all employees and all other kind of decisions which are made by the business are independent variable. So whenever you are hiring employees, one employee is hired, now he is totally under your command. Then you employ another employee, both are under your command, but both may have a relationship with each other. So they may dodge you, right? Or they may support you in terms of helping each other or in terms of fighting each other, right? So that kind of thing happens. If you have many employees, then you have to supervise them, because easily they can deceive you, easily they can shift the work, they can avoid the work, and they can do such kind of things. The point is that giving you this example just to show, whenever you are adding more variable as an independent variable, issues and problems and systems are going to be becoming more complex. And whenever system is becoming more complex, you have to take care of all these complexities. So that is why this multiple linear regression is a bit different from simple linear regression. So you have to be more considerate whenever you are going to apply this multiple linear regression compared to simple linear regression, right? So that is the only reason. Otherwise, whole strategy is exactly same, whatever we have already applied. So just give you a hint about what we are going to do in this, describe the relationship between several independent variables and dependent variables using the multiple linear regression. That's the same thing. Interpret, apply, ANOVA table. So ANOVA table is always there. In previous case, we have observed ANOVA table, analysis of variance table, right? That is showing the regression and the residual combination. F statistic. Compute and interpret the multiple standard error of estimate, the coefficient of multiple determination, and the adjusted coefficient of multiple determination, the R scale. The thing conducted a test of hypothesis to determine the whether regression coefficient differ from this. Actually, all these are going to be generated through directly whenever we are applying regression results on any kind of software. Excel we are using primarily, but you can also use the SPSS. Very sorry, I couldn't share you with you the files. I will try to do inshallah today, or just you, where some of you or any of you may remind me through WhatsApp regarding that late evening. So I will try to do that, right? And then I will mention where it is uploaded, so you can get it and you can install. Otherwise, Excel is there. You are using Excel, but still If you are going to use other software, you may have some hands-on practice on regarding that, so you are getting the same kind of results to that. Okay, first of all, this equation shows what? Anyone who can explain this equation simply, quickly? Ji. Daud, if you can explain. Muhammad Daud.
जी sir.
Now, if you try to explain this equation simply, what this equation shows. Ji, please.
Sir, multiple aggression हो रही है.
Okay, but what this equation shows, if you want just to explain this equation simply, how you will explain this? Kashan, do you have any idea? Ji, Kashan.
Sir,
Ji.
sir, A would be the y-intercept, right? क्योंकि हमने ये linear regression में भी formula किया था. And X would be the independent variables.
Right. This is the intercept, and these are.
Yeah.
These are what?
The
These are what?
Change of in Y when X changes, like
First
the
you will
amount.
say these are the parameters, right? So first you will say BIs are parameters, B1, B2, B3, BK are parameters. A is the intercept, right? First thing you need to explain. Second, the point you are mentioning, they are showing the slope of every variable with respect to dependent variable. I mean, dependent variable, how it is going to change with respect to each independent variable. So they are reflecting the slope of their respective independent variable. Clear?
Yes, sir.
And secondly,
Sir, excuse me.
please.
Sir, the X1, X2, X3, and X4, all of these are point on X-axis.
No, they are individual variables. X1 is one
They are
variable,
individual variable.
just like you are
Yes,
saying
exactly.
sales. Or sales is going to depend on what? Let's suppose
Well,
price,
it's going to depend on price, taste
right?
of people, income,
Taste, income,
fashion.
fashion. Usually fashion is going to be covered under taste. Number of
Okay.
customers,
Number of customers.
size,
Yes.
market
Yes.
size. If I may use word MZ, market size, right? So many variables are there. So you can identify actually with respect to X1, X2, X3, X4. Why we use same symbol? Because sometimes so many variables that we cannot use so many alphabetic letters just to avoid confusion. So you know that X1, 2, 3, 4, you can move any number of limit, X100, X1000. So there is no issue, right? So
But then why
identifying.
is A intercept?
Why is A intercept?
So, yes, sir. If these are only the numbers, if these are only the variables, random variable, they can be anything. So, like, matlab ki this
Correct.
is a function. In simple math,
suppose-
we would say this is a function where y is a independent variable, and the other one on the left side are on the right side are all independent variable that are actually affecting y.
Exactly.
So,
This is
and
sales.
A is a constant.
This is sales, and this is any variable you can take at a time. Xi,
Yes, sir.
right?
X1.
X1,
Yes, sir.
X2.
X24.
And with
Yes, sir.
respect to every variable, your intercept is going to change. Let's suppose X1, this is for X1, and it may be this is for X2, right?
Yes, sir.
jointly all these intercepts as a whole, whenever you are going to take all these variables in consideration, then you are taking the average of these intercepts, right? So as a whole or jointly as on average, what would be the intercept for all these? So whenever you are going to mention this xi, so you will take that particular intercept on average, right? So it shows on average, if all these are zero, let's suppose no price is mentioned, no taste is mentioned, everything is zero, then how much sales are independently happened? It may be zero,
Right.
it may be zero, it may be
Yes.
something,
Yes.
right? It may be
Yes.
something. Getting my point?
Yes, sir. I'm getting your point. Like it's for the condition where like least affected by all the, if it's not being, if y is not
It
affected
is
by
just like
any of the
independent of
variable,
all other variables,
still,
independent of all
yes.
other variables.
So
Sometimes
that's a
in
constant
some,
value, right? So that's a
exactly.
constant value.
All these are
So that's a
constant.
constant. That's not y-intercept, right?
Exactly.
There cannot be y-intercept because y-intercept have to be a dependent, and the dependent is y itself. So you guess, sir. I understand it now. Thank you, sir.
The
Thank you very
point
much.
is that
Y-intercept. So y-intercept is the value when all the x's are 0. So technically it's not depending on anything. It's 0 when x is 0.
just like intercept may be here, intercept may be here, automatically x size are zeros. You are going to be, whenever you identify intercept, you are at this 0 point. But some sale is going to be represented. Let's suppose in case of sales, you may say that if there is no price, no taste, then there is no sale. Okay, we may start from 0. But in case of just like food consumption, then if there is no income, still food consumption is there. So there is no 0. It's starting or intercept is not 0, right? So in some cases, your intercept may not be 0. It is some positive value. In some other case, just like in case of savings, it may have negative, or in case of supply of some normal product, it may have some negative slope, right? I mean to say, because at 0, it's not going, savings are not going to be saved, but they are going to be used. So savings become negative. Getting my point? So this intercept may exist. It may be positive, it may be negative, depending upon the structure of the system, how system is working. Clear to everyone? Dawood, you are clear? Kashan, clear? And both of you?
Yes, sir.
Okay.
Yes, sir.
Now we are another point I just want to mention, because in previous discussion it was mentioned A is constant. Generally B1, B2, B3, all these are constant. Actually A is that constant which is not going to be multiplied with any variable, so it is just remain as constant. But B1, B2, B3s are those constants which are multiplied over the slope of some independent variable. Therefore, they are called parameters. So whenever you are mentioning them, you are saying parameters. And in simple word, what is parameter? Parameters actually identify the limits of particular or structure of particular variable, right? So what are the parameters in which you are going to work, right? So that is kind of situation. Parameters actually shows the structure or the limitations or overall scenario of that particular variable, right? Just like if this is price, then what is the sales and price, how they are connected? What are the parameters of this price? Mean how much change in price you can affect the sale. There would be some limit. It is not possible that, let's suppose if you make price 0, then you can sell everything. Maybe your sales, your products are so much produced that even at 0 prices, people are not going to get everything, right? So still you have some amount left with you. So different kind of structure exists with reference to different kind of thing. Just like in case of simple medical medicines, if medicines are totally freely available, then those people who are not sick, they are not going to buy these medicines. But in case of food, situation is totally different. Okay, whenever we are going to apply this linear regression, multiple linear regression analysis, keep one thing, we are going to pick few variables. Actually, purpose of this multiple linear regression is to create a relationship among different set of variables, identify the dependent variable. If already you know the dependent variable, then you will go for regression analysis. If you don't know about which variable is independent and which is dependent, is there any case of such kind of situation? Is it possible that variables are mentioned and you don't know which is dependent, which is independent? Anyone? Bilal?
Sir, I cannot think of any right now.
Okay. Ji, Bilal? Dhyan Gondal?
Yes, sir.
Do you have any idea about it? Actually, in real life,
Actually, my internet isn't working. It's fluctuating. So,
Sir, हमने last chapter में नहीं कहते that we decide which variables can be independent or dependent.
exactly.
Like we have the variables, we decide which one we want to keep independent or dependent.
Exactly. You are correct. You are right. In some cases, variables can be identified because that may be of your choice, that you have to set a specific variable as a dependent variable, or you have to identify a specific variable as an independent variable, right? Because you know the structure of the thing. Just like in case of demand and supply equation, you already know quantity demanded or quantity supplied. It should be the dependent variable, and all other variables which you are going to take, just like price, taste, income, these are independent variables, because you know the whole structure of demand equation or demand relationship or supply relationship. In case of production, you already know output is dependent variable and all inputs are independent variable. So you know the structure. But in some cases, you don't know the whole structure of the phenomena. In that case, you are incapacitated to identify specific variable as an independent variable, because there are cause and effect relationship. One variable affect other variable affect other. So variables are interdependent. Most of the variables are in that situation, it's really difficult to specify one variable as a originally independent variable. Mean one variable may be independent for a time, but other variables may be independent, dependent to the same variable is dependent on some other time. Just like if you recall macroeconomics equations, y is equal to c plus I plus g, and then c has consumption function, s has some consumption function, then you have this I has investment function. So this means whenever consumption function you are talking, c is dependent variable. Saving function c s is dependent variable. Investment function I is independent variable. But in equation y is equal to c plus I, they are independent variable. So this means just like in case of general equation situation, you are going to face that kind of structure. Therefore, in that case, you have to depend on other procedures or of estimation, just like this multiple integration analysis may be applied, factor analysis may be applied, and simultaneous equation models may be applied. So multiple options are available through which you can find out the relationship between different variables. And in that case, you actually try to identify which is more suitable dependent variable and which are other independent variable, right? Mean to say, it may be with reference to time frame that in this time period, this variable plays vital role, so it remains dependent on many other independent variables. In some other situation, another variable is playing vital role. So in this way, just like for simple understanding of your under economic example, in some countries, in some time period, agriculture is dominant. So all other are depending, variating and affecting the agriculture. Agriculture sector is independent and all other are